Okay, so let's take a peek at this one, see how you're doing. I know some of you might not quite be done yet, but so we have Tim and Pete here. And one of the first things we're looking at is the number that each of them have. Number of cards. Which one is going to be X? Pete is. What's that going to make Tim? Tim has 5 times as many cards as Pete, so Tim would be 5X. Now we have the 132. Is that the total number of cards, or is that something else? That is the total number of cards. So we're going to add together Tim's of 5X plus Pete's of X equals 132. And now we have to solve that. So first step is going to be combined. 5X and X make 6X equals 132. And then divide by 6. X equals 22. So are we all done? No, Pete is 22. Tim is 5 times X, so 5 times 22 are 110. Now we're done. We've answered both. We've answered the question. We've identified both numbers. How many of you managed to get that one right? Show of hands. How many of you would have if I'd have given you an extra couple minutes? Okay. Let's do a couple more examples and see how you're doing with them. Let's say that Bob sells pencils for $2 and erasers for $3. If he sells twice as many pencils as erasers for a total of $210. Once again, how many of each were sold? Give that one a shot. I'll give you a couple minutes to try it. Let's take a look at what you have so far. So we're looking at the number sold. Which one is going to be X? Pencils or erasers? What's that? They're both going to be represented by X in some form, right? Which one's going to be just X? The erasers. Good. So pencils are going to be twice as many would be 2X. Good. Now, when we get the total of 210, is it going to be adding the amount sold? No, it's dollar amount, so we have to change this into dollars. And how do we represent the dollar amount sold? It's the price for each times the number sold. Pencils are $2 each, so it's $2 times 2X, which is going to be 4X. Pencils or erasers, sorry, are $3 each, so it's going to be 3 times X, which is just 3X. That's the dollar amounts for each. And they have to add up to 210. So 4X plus 3X equals 210. Now what? Combine 4X and 3X make 7X. Good. And then did somebody say divide? Divide by 7. X is going to equal 30. Where do we go from there? Well, 30 is X. That represents the number of erasers. 30 erasers. Pencils are going to be 2 times 30 or 60 pencils. Questions? How many of you feel comfortable with these types of problems yet? Okay. That's kind of what I was thinking. What's that?
Just do them a little different.
As long as you can get to the right answer, that's fine. I mean, it's perfectly all right to guess and check on these.
Sir, I want to just know how to do the easiest way and fastest way.
Well, that's the easiest way and the fastest way are not always the same. I mean, you know that pencils have to be twice as many as erasers, so it's just fine to guess. If I guess 10 erasers, that would be 20 pencils, right?
Yep.
And then figure out how much would that be? Well, it's $3 per pencil. Or sorry, $2 per pencil. That'd be $40. $3 per eraser, that's $30. That's only $70. That's nowhere near enough, is it? But when you do that, this is too small, which means I have to make my numbers bigger. If you look at it critically, though, I want it to be 210, right? The number I came up with is less than half as big, so I have to at least double those. In fact, if I look really close, 210 is 3 times of 70, right? So that'd tell me I'd have to triple each of these. If I tried 30 and 60 and then see what happens, that would actually work out. So guessing and checking, if you do it, I mean, it's not just wildly guessing numbers and putting out there. Your first guess is a wild guess. You have no clue whether you're close or not. But from that guess, then you can adjust up or down or whatever. I don't recommend it on all problems. I mean, this one, it wouldn't be terrible to do. You could zero in relatively quickly. But there are some more complex problems out there that would take a long time to zero in on a correct answer. Those of you that are going on to Math with Business Applications, there are some questions in that class where trying to guess and check would take you a while. But again, if you have a method that works for you or a way of setting them up that comes out to the right answer, please don't feel like you have to do it my way. There's always more than one way to get to that right answer. Okay, I'm going to have you do one more example just to see. Let's say Tom sells 8 cars less than Tammy. They sell a total of 72 cars. Once again, how many each? So here we've got Tom and Tammy representing the number sold. Which one's going to be X? Tammy, what's Tom going to be? X minus 8. Okay, so now what are we going to do with those? Do they combine as the total we're given, the total number sold? Careful. It actually is, right? Yep. They sell a total of 72. So we can just add these two numbers together. X minus 8 plus X equals 72. Now, I'll catch a couple people here. You got to be careful. These are both positive X's, so they combine to make 2X. And we still have the minus 8 equals 72. What do we do from there to solve the equation? Add 8. 2X equals 80. And then divide by 2. Good. X equals 40. So Tammy is 40, and Tom is 40 minus 8, or 32. That one a little bit better, a little easier? Maybe? Okay. We'll get used to those as time goes on. We did also mention that several times we deal with formulas. We're given a formula that helps us to solve the problem. So one formula we might get might be the simple interest formula. Our simple interest formula is I equals P times R times T. So let's say that we are told the amount of interest is $180. The principal is $6,000. And the time, be careful here. Our rate is going to be 0.1. Now I know we haven't done decimals yet, but we're going to shove that in here anyway. We're solving for the time. So we have I of 180, 6,000 times our rate of 0.1 times t. Before we can start solving an equation, we have to combine anything that we can combine. On the left side, there's nothing. On the right side, 6,000 times 0.1 is 600 t. So now we solve that by dividing by the 600. $600 divides out, you've got 180 over 600, and we're going to leave that just as that, like that for now. As a fraction, that's our time. Now, we haven't done fractions and decimals yet, but this is just one of the more common examples of a formula that you guys are going to see as you go on, where you just take the information out of a story problem and plug it in. I handed you the information here, but if that were set up in a story problem, you just plug it into the formula as you go. Okay, that's kind of our review from last class. Does anybody have any questions on the homework from last Thursday? Or on the quiz that you due on Friday?
Doing the homework and it locked up.
Yep.
So that's not just me, I don't think, or is it? Just me?
No, there's been some connection issues. If you log off and go back in, it should let you back into the homework. The quiz will not, so if you have that problem with the quiz, you got to let me know and I'll get it reset for you so you can start over again.
All right.
Good news and bad news. The good news is tonight we're only going to learn one small little topic and then do some review. And the bad news is the reason we're reviewing is next Thursday, or this Thursday, 2 days from today, is your Unit 1 test. So, let's hit our new topic and then we'll get on to a review in the second hour. We've talked about integers or negative numbers and doing calculations with them. Things like, negative 37 minus 24. To review, when we subtract, of course, with integers, we don't want to subtract, we change it to addition. So what would this become? Does the negative 37 change? No, the first number will never change. Subtracting 24 becomes plus negative 24. So now we can do negative 37 and negative 24. Both go the same direction. Our answer is positive or negative. Negative, do we add or subtract the values? Add them because the arrows go in the same direction. So that ends up being 61, negative 61. Or we had negative 12 times 9. When we multiplied with our integers, we looked at the signs. What's a negative times a positive? A negative. Then we just multiplied the numbers. 12 times 9, 108. We've looked at powers. This is 8 to the power of 3, which means what? 8 times 8 times 8, or 512. 8 to the third power just means 3 eighths multiplied together. So what if we have Negative 5 to the third power. That's negative 5 times negative 5 times negative 5, which is going to be negative 125. Good. If we're going to do that out, negative 5 times negative 5, negative times a negative is a positive. 5 times 5 is 25. Then we multiply by the last negative 5. Positive times a negative is a negative. 25 times 5 is 125. Have you guys all figured out how to enter powers on your calculator now? With the caret key or the XY key? So if you do negative 8 squared, try that and tell me what it comes out to be. Positive 64 or negative 64? Did anybody get a negative?
I did.
You did? The reason why it does that is you have to have the parentheses around it. Otherwise, your calculator is using the order of operations. It is squaring the, if you just do negative 8 squared like this, it is squaring the 8 first and then applying the negative. But if you think about it, negative 8 squared is negative 8 times negative 8. Anything times itself has to be positive. Negative times a negative is positive. So whenever you square something, make sure you get a positive result. Now up here, we did get a negative up here for the 125. So it doesn't mean every time there's a power, you're going to get a positive result. Let's do negative 5 to the power of 4 and see what you come up with. 625, good. Again, that's negative 5 times negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is a positive 25. Times another negative 5. Positive times a negative is a negative. 25 times 5 is 125. The negative 125 times the negative 5. Negative times the negative is a positive. 125 times 5 is 625. So it is a positive 625. Now, before I go any further, can anybody tell me whether this will be positive or negative? Negative. Why? There's an odd number. I could think of it as just the 625 times another negative 5, can't I? Because that 625 is 5 to the 4th. That's 4 of them already. So this is going to be a negative 3,125. Do you guys remember what the rule is if you're going to take a negative number to a power? When is it negative and when is it positive? Odd and even, exactly. Negative 3 to the power of 6 will be positive because it is an even power. What's that? That comes out to be a positive 729. Negative 4 to the power of 5 is going to be positive or negative? Negative. Because this is an odd power. That comes out to be negative 1,024. What will 7 to the power of 8 be? Positive or negative? Positive. What will 6 to the power of 9 be? Positive or negative? Why is it positive? Didn't we just say odd powers? Turn there. I started with a positive number, exactly, on both of these. No matter what power, if I have a positive 7, doesn't matter what power I raise it to, I'm going to get a positive answer. Positive 6 is the same way. So that odd and even only applies if I'm starting with a negative number.
So the rule applies just when the numbers are different, negative and positive?
Yeah, well, just when this is negative is the only time it... Well,
Can the power be negative?
the power can be negative, but we're not going to look at that yet. That gets confusing.
But if they're different, that's
Um,
code is different.
No, if the power is negative, it can still be a negative answer. But that's getting kind of complex for us for this point in the game. We'll look at that later in the semester. But right now, the power will always be positive. Negative powers, you think about it, it's confusing to think of taking something times itself a negative number of times. So we've got to establish what that means later on. But just to answer your question, that will be a negative answer. So it is, having the two negatives does not necessarily make it positive there. It will not necessarily make it positive. It will not. Okay, so what if we have something like this? Evaluate p squared minus 3m plus 2mp for p equals negative 7 and m equals 3. You guys remember what evaluate means? It means we're going to put the numbers in where the variables are and then do our order of operations. So what's going to go in here for p? Negative 7. I make sure I put it in parentheses because if I'm going to enter that in the calculator, I need to make it come out. Minus 3 times what's going to go in for m? 3 plus 2, what's this going to look like? Times 3 times negative 7. This is 2 times m times p. So those are all 3 multiplied. So now my order of operations kicks in. Are there any confining symbols? Well, no, I do have parentheses, but they're not really enclosing anything. They're not making me do anything. They're just separating any negatives or numbers to be multiplied. So then I have exponents. I have the negative 7 squared, which will be positive 49. Next I have multiplication. I'm going to have this as 3 times 3, so this will be 49 minus 3 times 3 is 9. Now I'm really tempted to combine the 49 minus 9, but I can't yet because next I have to multiply. 2 times 3 is 6. And then next I need to multiply. 6 times negative 7 is negative 42. So now I go left to right. 49 minus 9 is 40. Plus a negative 42. 40 and negative 42 makes that negative 2. Perfect. What do you think? Not much fun? Let's try to evaluate four m plus d squared all over 3q for m equals 9, d equals 6, and q equals 2. I want you to try that in your notes. See what you come up with. So as we look at this, we have to replace the letters with numbers. So what's this going to become? I heard somebody start to say it there. It'll be 4 times, that goes in for m. Okay, there you go. 4 times 9 plus d becomes 6 squared. I know where you were going. You're just getting ahead of us. Is all. Sure. Then on bottom we have 3 times 2. So now now that we've got the numbers in for our variables, we have to follow our order of operations. And the first thing we have to do is to do everything on top. And up there we need to the 6 squared. 6 squared is 36. Then what? 4 times 9 is also 36. And then Adam, 36 plus 36 is 72. So the top is 72. What do you do on bottom? 3 times 2 is 6. And then divide them out. Perfect. 72 divided by 6 is 12. Not so bad? Yep. Yeah, that's fine. Yep. As long as you understand what it means when you're doing your work, that's fine. So an equation like this, -7 times x minus 3 equals -31. Let's see if you can apply our negatives there and give that one a shot. First step. Add 3. Very good. So that's gone. We have -7x here. What do we have on the other side? -28. Very good. What's next? Divide by -7. That's gone. We've got x equals 4. Perfect. How do you guys feel about the negatives? Are you getting a little more comfortable with them?
When you switch from one side of the equal sign to the other, doesn't that power change from negative to positive, or does it always stay negative?
Well,
You know,
there's a way that some algebra classes teach that you move stuff from one side of the equal sign to the other. And if you do it that way, then you change signs. But we're not looking at it as moving things. We're taking stuff apart. So here, this was a -3. To get rid of it, we had to add 3 because a +3 cancels out a -3. So we canceled out.
same on both sides.
So we have to do what we do to one side, we have to do exactly the same thing to the other side. But you'll notice that what we did here is the opposite of what was already here to begin with. But the reason it is the opposite is we had to do the opposite to get rid of it. Does that make any sense?
Yep.
Okay. Well, let's go ahead and start just a little bit of our review and see what you remember. Let's see if you can take something like try that in your notes. See what you come up with. So what would step 1 be? 5 times 4, which is 20. And then 7 plus 20 is 27. Perfect. And then 54 divided by 27 is 2. Perfect. Try that one in your notes quick. So what do we have to do first? We have to divide. 18 divided by 6, which is 3. This one doesn't work out very well, does it? This should have been a... That was the wrong number there. That was supposed to be that's supposed to be divided by 10 is what that was supposed to be. That was supposed to be divided by 10. That was my mistake when I wrote that out. Sorry about that. Let's do it together with the right numbers in there that it works out. Instead of giving you like point whatever that was. So now what would we do next? 7 plus 3 is 10. I can take out the parentheses because that's a single number now. Putting in my multiplication in front. Now do I do 10 divided by 10? No. I've got multiplication and division. I do have to go left to right. I would have to do the 2 times 10 first. Then I could do 20 divided by 10, which is 2. And then I changed that to divide somewhere. That's got to be a plus. Little hamster's just not getting the wheel very well tonight. Sorry. So now we've got 8 plus 2 is 10 plus 3 is 13. I'm not even going to ask who got 13 because I didn't have the problem out right, so you couldn't do it. Well, let's try one more, see if I can keep it together here. Just once, maybe. Try that one in your notes. See if that... So I've got the fraction bar, which means I have to do everything on top first. On top, what is the first thing we need to do? Multiplication. 5 times 3, which is 15. So now we have negative 21 minus 15 gives us what? Negative 36. Okay. So it's negative 36 on top. On bottom, what do we have to do first? Divide. 42 divided by negative 7 is negative 6. What's next? 2 times negative 4, which is what? Negative 8. Now we're at one of those weird problems where we have negative 6 minus negative 8. We're going to change it to negative 6 plus positive 8. So now from 0, we've got negative 6, positive 8. That's going to end up being positive 2. So negative 36 divided by positive 2 is negative 18. Very good. Any questions on that one? One little easy one before we take our break. What's that now?
Well, on the bottom, it's negative 2 minus 2 times negative 4. But if you do negative 2 times negative 4 first, but it's looking at you the other way, left to right. So,
So negative 6 minus 2 would be a negative 8. Nope, that won't come out. Because negative 6 minus 2 would be a negative 8 times negative 4 would be a positive 32. If you punch it in most of your if you have a scientific calculator though, and you punch that in just like it reads, it will spit out 2. You can do the same on top, it'll spit out the negative 36. But it's hard to make it do both. So I recommend in a problem like this, you do that, write down the answer, do the bottom, write down the answer, then divide them. A problem like this one, if you use parentheses on your calculator and enter it just like it is, it will actually spit out 13. So your calculator does do order of operations if you can make it understand what it's doing. The problem is making it understand the fraction bar, because some of your calculators do have that, but most of them do not. So let's take a look at 11 times, or 11 minus a negative 8 times 9. Try that in your notes quick and see how it comes out. So we start by doing what first? Multiplying negative 8 times 9 is negative 72. We have 11 minus a negative 72 becomes 11 plus 72, or 83. Let's go take our break. We'll come back at 4:30 and we'll continue reviewing for the test.